Hello, welcome, and thank you for attending today's webinar on cloud scale, BGP, and NetFlow analysis. This is Alex Anthoniwani. I'm Chief Marketeer at Kentik, and today our speaker is Kentik VP of Product, Jim Fry. Jim has over 20 years experience in network management products and technologies and brings a lot of great perspective on network management tools based on getting to know the industry very broadly as an analyst with Enterprise Management Associates, but also through his time working on a more kind of deep basis on network management solutions at NetScout, Micromuse, Cabletron, and Agilent. Before we get started, I just want to let you know a couple logistics. First of all, this is going to be a 45-minute session. I think we're going to try to keep the presentation section quite a bit under that, a little bit under that. And then we'll have some time at the end for Q&A. But there is a panel for questions that you can ask and type those in, as well as for feedback. In addition, there is also a panel for attachments, and we have a couple of white papers posted there. So with that, I'm going to hand this over to you, Jim, and I'll pick back up at the end for some Q&A. Jim?
Thank you, Alex, and thanks everyone for joining us. I think we have an interesting topic today. We have some really cool stuff that we want to talk about with respect to bringing together BGP and NetFlow data. So the agenda here, what we're going to talk about, we have to set some context first. So I will make everyone suffer through the, obligatory, why are we doing this? What are the pain points part of the presentation? But then, use that as basically a launch point for saying the context of why this kind of combination of data is a really interesting and powerful and useful combination of data. And then we'll talk about, the main title that we have today, which is how do we deal with it? And in particular, how do we deal with it at scale? Part of what we will do is show you the way Kentik is handling this challenge, and we'll talk about what our design criteria were in going and trying to solve this problem. And as Alex mentioned, we'll try to leave a little time for Q&A at the end. So the problem set that we've been trying to address, really hasn't changed substantially over the many years. We think about the problems, the questions that need to be answered. These are the same questions we've been asking in network operations for, honestly, decades. Where's the problem in my network? Is it in my network? And if it is, where is it? What's going on with the load on my network, the traffic on my network? Is it real, legitimate, organic? Is it expected or not? Is my service quality or my deliverability across the network meeting the expectations that I've set, both internally and externally? And then really, am I taking advantage of the resources that I have in hand in order to deliver network connectivity? So what's changed, though, is some of the dynamics around this, and there's two key things I think that have really changed the landscape for dealing with these kind of answers. One of them is the introduction of just continued growth and scale. The volume of traffic that's going across the network keeps going up and up and up. Of course, that throws off more and more data. We'll talk about how we have to handle that. And the other is the expectation for the time required to answer these kinds of questions keeps getting shorter and shorter and shorter. So we say in the title, they're needing instant answers. Really, the days are past when you can afford to wait an hour to get an answer to a service interruption question. You've got to be on it. You've got to be on it right away. And so we really need to move to a mode where we're providing the sort of information that operators need to answer these questions quickly, meaning like within minutes of their occurrence at any opportunity. So when we talk to folks who are in the trenches and we're talking to them about how they're trying to move to this more instant answer sort of strategy in the operations venue, the kinds of things that we keep hearing that people are looking for are pretty consistent. So for instance, they're looking for just clarity. They're looking for accurate visibility, things that are giving them some clear insights into what's going on, and they need the data right away. They can't wait for a half hour or 20 minutes or 10 minutes or even 5 minutes is really almost too long in some cases, in a lot of cases. They're looking for, there is a need for alerts. There's a lot of alert fatigue out there. There's a lot of tools that have been designed to deliver sort of sustained monitoring of activity and traffic, but very few of them where the alerting capabilities are being turned on and used. And the reason is too many false positives, too many false negatives, alert fatigue. There's still a desire to have, that sort of real true alerting in place in a part of the, part of the solution. There's always a need to look for completeness in the data sets, and really this is a combination of both data that gives you a complete end-to-end view, but also the depth behind that, so that you can get into the weeds when you need to, like try to get the bottom of a thorny or difficult issue. There's also a need for, when navigating through that data, being able to get through it easily, quickly, being able to move and pivot and drill down and move back. So really flexible exploration of the data to ask questions or to get questions answered that you didn't think about ahead of time is essential. And this is one of the things that becomes more and more challenging with the volume of data that we're talking about coming from monitoring systems. And finally, somewhat tongue-in-cheek, people are just looking for tools that get the job done. And we say tools that don't suck, and it's, yes, okay, part of that is whether or not the features that are there are adequate or not, but it's more than just that. It's not just about, are the features there? It's about how much time is it taking to deploy them, to maintain them, to use them to answer questions, and how expensive is it? So I guess there's multiple dimensions to the suckiness factor of a lot of tools that are out there today, and ample opportunity to do a better job. So the next question that will come to mind here, and we want to finish sort of setting context before we get into the topic today, is what are the data sets out there that can really help with the instant answer problem and deliver the sort of capabilities we just talked about? And one of the key questions is which can be used to really be cost effective in the process. There are really lots of data sets out there for monitoring. In the years I spent as an analyst, I spent a lot of time looking at the mixes that people were using, what purposes they were using them for. And during that time, I really found pretty clearly, and I think anyone who's in a network operations role knows this, but just for those for whom it's not obvious, there's a sort of primary monitoring data choices, and then there's lots of other supplemental sets of data that can be helpful. So the primary sets tend to be these three categories. There's polled type statistical data that is, in most cases in the network, it's SNMP. There's other polling type regimes as well, things like WMI, that's more server oriented. That kind of data, very easy to get to. It's not a huge amount of data to collect normally. It gives you a good idea of what's going on device by device, but it doesn't really tell you what's driving activity. So there's no traffic detail, and it really truly is not. It's the anti-real-time data set, really. It's most frequently gathered on a 15 or a 10-minute polling cycle. Some will go down to 5 minutes. Some will even go down to 1 minute. That's pretty rare. And you can even do relatively live updates of SNMP data, but not at scale, only on a very, very focused basis. So while it's good for certain things, it's really lacking in terms of, in particular, traffic detail and real-time nature. Flow records, which is a lot of what we're going to talk about today, things like NetFlow, SFlow, IPFix, I have been around and used for mostly planning purposes and some troubleshooting purposes, but surprisingly have not gotten a lot of attention as being a true operational monitoring source until I think just in the last few years. It's really started to gain some traction, and that's where we're going to spend a lot of time looking at how to leverage that as a data source today. In particular, the big advantages for these, for flow records, it gives you the detail of the traffic, source, destination, port, protocol, ASN. There's plenty of details in there. It's not as complete as the next one we'll talk about from an application detail perspective, but it's much more data than you can get from SNMP. It's also very cost effective because it's lightweight. The devices are the sources. You do have to build some collection and analysis architecture, yes, but you're not spending money on instrumentation typically for flow records. You can, in some cases that does make sense, but in most cases you don't need to. The big disadvantages here for flow records, it's really not true real time. It's near real time, so we're talking sort of the several seconds to minute time horizon. It's about as real time as most people can digest, but it's not true real time. And as I mentioned, while there is incompleteness here in terms of the upper layers of the stack, both from a performance and an application detail perspective, some of the newer forms of flow records, NetFlow v9 and IPFix, can include metrics such as these if the devices that you are using can support those measurements. They can be included and transmitted in the flow records. One other thing to point out here, and this is maybe a disadvantage or just a basic characteristic, we're seeing the volume of data that the volume of information coming across the flow records is growing rapidly. It's getting to massive state. So it's getting harder and harder to actually manage that from a data management perspective. The last one here is a primary source, packet inspection. Packets, really you're going to handle them in one of two types. Either you're going to do streaming inspection and generate usually some sort of metadata. I'm saying XFlow there. This could be a flow record. It could also just be metadata from whatever the system is that's doing the inspection. And it's also common to stream this to disk so you can do forensic analyses. The advantage of the packet viewpoint, it really truly is the most complete data set from seeing everything that's going on in the packet streams, and it is true real time. And one other thing that people don't often remember, it is actually vendor independent. SMP and flow records, it does depend on what the device vendor that you're drawing data from has decided to implement. But on the packet inspection side, packets are packets, and you can read them regardless of what vendors are being used to provide the network infrastructure. The big disadvantages, really the major disadvantages around packet inspection is the cost of instrumentation. Usually deployed in appliance mode, the big drivers of cost there are the appliances themselves, as well as the need to continually upgrade those appliances to handle growing traffic rates. So 10 gig instrumentation for packet inspection was a lot more expensive than 1 gig instrumentation. And we are, on the verge of 100 gig being deployed in large scale. That's going to be even more expensive. And this is just the nature of, the technology and the hardware needed to keep up with the data rates we're seeing. And finally, that packet captures, they can be really big too. It got clipped a little there, but packet captures can be massive. If you use them on a point and forensic basis, it's not too bad, but if you try to use them on and save them on these large scale systemic basis, you can eat up a lot of this volume pretty quick. So I want to talk a little bit about secondary data sources because they're interesting for our conversation today. One of the most common ones that we hear about and are asked about is syslog data. In other words, what can you get out of syslog? Great data source to look for and to reveal really unique things and pieces of information on individual devices, on the things flowing through those devices. A great example of this is firewall logs, for instance. Lots of detail in there. Part of the challenge with this is it's a huge volume of data oftentimes. It's semi-structured at best. There really are no standards for this. So you almost need a separate set of tools that can handle very flexible search-based analysis. Good complementary set of data. I'm not sure I know anyone who's using this as a primary network monitoring technique, but as a supplemental view to help reveal certain events and certain activities, yeah, it can be really useful. In the middle there, and something we're going to spend a lot of time talking about today is routing data. So routing data, examples I have here, OSPF, BGP, IGRP, internal versus external. BGP is a sort of external view of routing, and we're going to talk about why that's particularly valuable here shortly. The interesting thing here is it's a different data source. You got to go collect it, but it does give you specific details from which you can understand pass through the network and the path that any particular set of traffic is taking. And it also is a way for you to gain insights into, beyond your own network to see how traffic is traveling across other entities that are coming together to either deliver, wide area connectivity and in particular internet type activity. So really helpful for being able to see into what we often in many years in the past call the service provider cloud and see really where your traffic is going in the process. Disadvantages of this data as a standalone data set is it really only is address data. It does not include any awareness of the traffic itself. And it's a little more subtle to gather the information. You do have to set up and establish peering with routers if you want to get the dynamic updates. So it's not quite as simple as some of the other data sets to make sure that you're gathering all the time. The last one I'll mention, just because I've always been fascinated by it as another supplemental data set, is synthetic agents, things that can help you understand that both the availability and performance of very certain types of features or applications. You can sprinkle these inside and outside your network just to keep an eye on key apps and functions and services and do it 24/7, regardless of whether it's actually being used. The downside of these is they really are just a test. They're not measuring actual real activity. They only test what you set them up to test, and so they're only seeing a narrow view. So useful, again, not a primary data set, but a lot of folks use them as a supplemental way to keep an eye on things. So with all of that background, what I really want to do is talk about why we have multiple data sets and why it's important to think about bringing some of these data sets together. In all of the years I did independent research, all of the conversations I had with folks who were using these tools kept coming back to the same conclusion, is that no one data set is going to give you everything you need. You need to have multiple data sets so that you can have the view. Each one's going to have its strengths and its weaknesses. Each one's going to help you look at certain things, but not at others. So you never know which one's going to really be the one you need, given any particular problem you're trying to look into or any particular challenge you have. And the real secret sauce and magic, but challenge as well, really comes from bringing these together and correlating them. And you can then do some pretty powerful things. So for instance, I have some examples here that were common from dialogues we've had, as well as the research I was doing prior to coming to Kentik. One of the great ones is looking at log data to recognize when there's been a configuration change, and then see and correlate that with changes in the behavior of the network or the patterns of traffic. Sometimes for the good, sometimes for the bad. Sometimes what you're trying to look for is, why is this strange thing happening? Oh, yeah, sure enough, there was a configuration change that came through in the logs. Another one is correlating sort of negative, broad trends and changes in traffic levels, but then also being able to peel back the layers and understand, well, what traffic really was driving that? Was it a data backup happening at the wrong time of the day? Was it some sort of campaign, a commercial campaign that suddenly drove a huge spike in traffic? Let's say the typical example is the online version of the Victoria's Secret fashion show, right? Something like that. Could be legitimate, but this is also where you were looking for recognizing things like DDoS attacks. So DDoS looks like a big change in traffic, but it's an attack. It's malicious instead of being organic traffic. So understanding the underlying traffic causes is really important. And the last one, and the one we're going to dive into more here today, is bringing together routing data with traffic data. And this provides you some really powerful capabilities that we think are definitely worth some time detailing and explaining for you. Not everyone would think about doing this up front, trying to bring these data sets together. A lot of people will look at BGP, they'll look at their traffic, but why should we correlate them? Well, it turns out that when you bring these two together, you can answer some really pretty powerful and important questions. But the questions really do depend on what type of an organization you are. So actually, before I talk about providers, let me just mention that if you have an autonomous system number assigned to you, that means that you are doing some sort of non-trivial routing. You are doing at least multi-homing and or you're trading traffic and peering with other providers and other networks in order to have some degree of control over how your network flows out over the internet. So if you're a provider and your primary set of objectives is maintaining and improving your services and driving service revenue, this kind of combined data actually gives you visibility into how each of your subscribers and your peers and your neighbors are behaving. And that can really help you with both driving some new opportunities, finding new customers to address, controlling cost, and or probably more importantly, recognizing where your peering relationships are working or are not working to expectations. We'll show some examples of these and some screenshots later too. If you're a web services sort of company or a web commerce company or a content provider, in this case, you're looking at using this information to understand where geographically perhaps your customer concentrations are and how they're reaching you from a network perspective across the internet. So any organization that really is basing their whole business model on having effective, efficient connectivity to their customers over the internet, there needs to be constantly monitoring this and recognizing where there are either problems coming from specific paths or routes or providers, or opportunities to improve and simplify. And I'll show you some examples of that in a minute too. So really, it comes back to then understanding who they should be peering with, where they should be adding new peering points, who they should be negotiating with to make sure that they're giving the best possible customer experience. Enterprises are part of the mix here too. There's a lot of enterprises that have autonomous system numbers assigned to them. Most of them are using it for multi-homing their service provider connectivity, either for reaching out to their extended business community, or even reaching their user base. In particular, any enterprise, their customer base, any enterprise that has a significant amount of transactions, sort of electronic transactions going to drive their business, and they're connecting across the internet to other organizations to do that, should be taking assessment, or should be taking a look at this data, because it can help you recognize how the immediate providers you are using are doing their job, how to compare, and also recognize cases where the business partners or the end customers you're serving may actually be concentrated through yet another provider, where if you actually went ahead and set up direct relationships with that provider, you could be reaching them more quickly, reducing any sort of risk to operations and performance. And another aspect of this is helping enterprises just build a better understanding of the bigger systemic world that is the internet, and how the internet is performing when there is a problem with a particular provider out there. Is it a problem that's just affecting an individual enterprise, or is it affecting everybody? And that kind of information becomes available by sort of correlating this in NetFlow data with BGP routing data. So next up, let's talk about, once we have sort of some basis for realizing we want to do NetFlow together with BGP, how do we achieve cloud scale? And this is where we're going to turn to what we think is key to success is treating this as big data. I'll tell you why we think that is. Primarily, the challenge we've seen with a lot of the existing tools out there is they are getting saturated and having trouble dealing with the volumes of data. They're having trouble keeping pace with the increases in data volume and then basically network throughput, depending on which type of data source you're talking about, that have come with the ongoing growth and the sort of the latest evolutions in the market of cloud and SaaS and big data. So big data as a new technology, relatively new technology, is really a nice fit and a way to describe and handle network monitoring data, in particular large volumes of NetFlow data. The reason this is that it's, network monitoring data is big in volume, yes, but it actually meets all of the traditional big data 3V tests. Yes, there's a lot of volume. We're talking about, billions of records of data the Kentik platform is inserting in the back end every day. Even, millions per second, not unusual to be seeing those sort of volumes of data. So that's a volume thing, and in part a velocity thing, but there's also variety, as we talked about. We have a lot of different sources of data, and you want to bring them together, and you want to correlate them. You want to look at data relationships. You want to find relationships that may not be obvious to you. So it does meet all of these typical volume, variety, and velocity tests. And the data volumes that are being stored of network monitoring data can be just as big as other big data applications out there. And the other reason why big data is a good place to look for answers here is the architectures in the market today. Really, this represents some of the cutting edge in terms of data manipulation, data science, data analytics, flexibility, and openness for bringing data in quickly, easily, cost effectively. And running quick and getting answers in a timely manner, as opposed to waiting for answers forever. So there's really good sort of forward-looking motion and innovation in big data architectures that is a lot more balanced and I'd say lower risk than making big bets on proprietary data architectures that have to do all sorts of unnatural things in order to scale gracefully. And in particular, around the combination of NetFlow and BGP, But we think that that sort of strategy can help solve some of the specific challenges we hear about when I'm talking to folks about the existing tools they're trying to use to solve this problem. So things like a lack of flexibility specifically to move and migrate and explore data quickly and easily. A lot of the existing tools out there, you have to predefine the views you want to see. And if you didn't see it in the view that you defined, well, you got to define a new view and run a new report, gather a new set of data. Another problem is completeness. We talked about this early on. A lot of platforms, in order to not melt down under the load of the volume of data that can come in these days, do summarizations or aggregations of the flow data. And when you do that, you lose detail. And so while it helps you at a very high level see what's going on, if you want to drill down in and see details, they're gone. They're not there. You have to go to a different tool or a different data source. So that has been a big barrier to success for a lot of the existing tools out there. And the last one is speed. You really do want to be able to pull large sets of data, look across several days. Our own platform goes up to 90 days. Look across multiple peering points or multiple routers, multiple data sources, and looking at aggregations of data that can be quite large in volume, but you want answers within minutes. You don't want to have to wait hours for those. And there are plenty of the older tools out there that are challenged to return timely results once the data sets get large. So how do you get there? If you buy in now, if you're still with me and you buy in that big data might be the right answer to this, how do you get there? How do you establish a big data platform? How do you get it in place to do these kind of analyses? Well, from what we can see, there's really kind of two core choices to be made architecturally. One is you can build your own, BYO. And if you build your own, there's a lot of tools out there. You can pick a backend. You can pick a big data distribution. And you can pick reporting and analysis tools. So a lot of folks have some expertise in Hadoop or in Elastic or in some other backend. There's plenty of them out there, Mongo, Cassandra. And then there's a number of tools out there too. There's the Elk stack. There's a variety of tools for reporting against these backends. And a lot of these tools are open source and they seem to be relatively free, but of course, nothing is free. You still have the costs of the operating platforms. You will have to do your own degree of integration with data sources and get the thing stood up and running, which is going to cost you dev time. And then you got to keep it up and running, which is more ops and admin time. Now, so there's a lot of dollar signs there. You do end up still spending money. And the other challenge that we found is that a lot of folks still never quite get to all of the capabilities they're looking for when they build their own. It's a constant ongoing dev process. So luckily, the way the tools market works is a lot of people will go and try to build this because there's nothing out there. But eventually someone comes along and says, hey, we got this, and introduces an option where they do all of that hard work for you. They do the build, the optimize, and the ongoing operations, and then just offer it as a service. Either as a product-based stack that you can buy and deploy, or increasingly now SaaS as a true option, an alternative. And then instead of spending capital dollars on an operating platform and expense dollars in ongoing administration and management, you're just buying a subscription to a SaaS and send the data and get the results. And that's, of course, the springboard for talking about what we do at Kentik. So at Kentik, we built that SaaS-based big data-centric backend, and we're offering this as a service, including a whole lot of capabilities that go above and beyond NetFlow plus BGP. And that's what we're talking about today. And one of our driving objectives is expressed, again, somewhat tongue-in-cheek in the upper right there, that we're really trying to deliver a solution that does NetFlow analysis and collection analysis in a way that sucks less. Sucks less in all those dimensions I was mentioning before. Easy to get to, easy to use, quick to deploy, low cost, very effective. And the goal here is applying the big data sort of architecture at a cloud scale to meet some of the NetOps challenges. So we do this by hosting a big data backend that we operate. We built, it's actually a hybrid architecture that's quite similar to some of the open source distributions, but we took it and optimized it specifically for this use case and this network monitoring application space. We take data in and we make it available through web-based front end. I'm going to show you some screenshots of that in a minute. We also do automated alert monitoring, and then we also have a RESTful API that we offer for getting data back out of it. So the back end really is true multi-tiered clustered backends. It's clustered for easy scale, as well as handling load balancing, so we never drop any data on the way in. And we also can handle lots of live active requests against the back end. So it's a true big data architecture. The core data store is columnar in nature, but the real magic is how we get data in very quickly at massive volumes, and then how we also allow rapid query response at massive volumes and very quick speed. A lot of balancing and tuning that we've done to make this commercially viable. So before we get to Q&A, I want to kind of walk you through a couple of screenshots and just talk a little about what this ends up looking like to most operators. So we have our obligatory portal dashboard that shows a variety of views of the data. Here we're showing a combination of things. Probably for today's discussion, one of the most important is in the upper left. We're watching, in this case, for changes in AS paths. So BGP routing updates. In fact, I've got a better example of one of those in just a minute. We also, of course, track all the top traffic flows. We do the top-end type analyses, although you can look at them by all sorts of different combinations, whether you're looking interface to interface, port to port, source to destination, and combinations of ways to look at the top talkers. We also have added in, besides BGP data, we're also grabbing GeoIP data, so we can categorize the information and show it to you in terms of source or destination geographies. And this is really helpful for a number of reasons, which I'm going to show you actually in one of the BGP analytics screens about how we're going to turn that into something that we use for the BGP analysis. But really importantly, the example here, for instance, is this is some live internet read news service traffic that we have an opportunity to monitor. And it's showing that there's a lot of traffic coming to and from the Netherlands. But it's a mix, and it's a number of other types of countries. In today's world, you are getting data from and sending to all sorts of different geographies. Some of which you would expect, and one of the things you're watching for are the geographies that you don't expect, right? So here's an example of one of the ways that the system gets used more specific to today's topic, which is looking at sort of combination of BGP and NetFlow. Here we're looking at NetFlow records and where the AS path changes. So this example shows route changes that happen, and going from it all has to do with, this is a little small, I'm trying to read it, 10796 I think is the ASN that's getting changed. That's Time Warner Roadrunner traffic, and from this particular viewpoint, it's getting moved to a couple of different ASs. When that happens, that's something to pay attention to, because that can have a potentially dramatic impact on performance and service quality for anything that's traveling across that particular destination AS. Another common way that folks will use our platform to look at this kind of information is then to look at top talkers by AS. So the example here is looking at Highwinds and Pixnet, as ASs, destination ASs, and looking at the top talkers. Source ASs. So besides all of these kind of top-end type views and sort of change views, we've also introduced, and you'll be seeing here for the first time, some BGP analytics. Now, for us, peering analytics is a new feature. It's in beta right now. It's going to be out soon. But what we're doing is showing in a very graphically intuitive form the multiple hops the traffic is taking from your network out to the outside world, to all the end destinations. So, for instance, the example here is showing ASN by destination country paths. So what you're looking at here is the source network, my network, is on the left, I've got, in this case, two primary providers providing the access to the outside world, to the internet, and then a whole series of providers that then I'm hopping through to reach these various different end destination countries. Now, so there's some interesting things you can see. Of course, the end destination countries on the far right. The biggest bar there is all U.S. traffic, but I've got a fairly big slice of traffic going to Germany. In this case, a lot of my U.S. traffic is going through one of my primary providers, but the other one is really quite diverse. Anything going through that other provider is getting split and going through sometimes an additional 1 hop, sometimes 2 hops, sometimes 3 hops. And so once you get to that level, it's worth studying and understanding, is that really tortuous? Is there anyone in there that I'm serving that should be getting high quality service who's actually going through too many hops? And each hop introduces some risk for performance and connectivity. You know, this can look a little different here depending on the data set you're looking at and the time range you're looking at. This is another view of the same kind of thing, BGP paths over time. Actually, let me jump to the next one here. This is traffic by origin AS, in other words, something we would call last hop. Here, in this particular view of the data, you would be looking for things like unusual or unexpected traffic destinations. You would use this to understand, is the traffic patterns, you know, do they look like logically the kind of volumes you would expect for each of the relationships in the end destinations? And it actually can help you, especially if you're a content provider, in recognizing where you have pools or concentrations of active users that you may or may not be aware of, or may or may not actually be, you know, in the best position to serve well. Another way we can look at this is traffic by transit AS. Now, this is actually really helpful for a number of reasons. The particular screenshot you're looking at here, we have a feature and ability to just basically hide from view the first hop, so you can just focus on the second or subsequent hops. And with this kind of information here, you can look at the opportunity for finding new customers. If you're a wholesale provider, for instance, you know, these second hop transit ASNs really can be your potential customers. It means that you know, they're 1 hop away, and if they're a significant chunk of your traffic, you might want to go talk to them about you know, serving them directly. If you're a content provider, this is another way that you can see where you have concentrations of users, or you can also understand for concentrations of users that you don't feel are getting good service quality, you can understand exactly which transit providers or which ASs they're going through to reach you. You may want to subsequently reach out and peer with that AS or set up a commercial relationship with them, or you might want to try to find another way to address that concentration of users. So with that, I think I would like to try to wrap this up, hopefully give you a taste for the kind of things we're doing with NetFlow and BGP. There's, of course, a lot more detail and not nearly enough time to go through it all here, but I want to save a few minutes for some Q&A. I hope you'll take away from this a couple of key things, which is, you know, some of the reasons why you should be interested in NetFlow and BGP correlation up front, and then some concepts about the technology you're going to need in order to get to this kind of analytic capability at scale. And with that, Alex, I'm going to hand back over to you so we can take any questions we might have.
Okay, great. So first of all, just want to encourage if there are any questions to type them into the Q&A panel. We've got a couple of here. One question is, how does the data get into the Kentik backend?
Right, that's a great question. It's one we get regularly. So we have multiple ways to do this. You can either set us up to receive data, you know, point your NetFlow sources to our public IPs. We have some folks who do that. You can also, we can set up a local collector proxy on your own site, in your own environment, that will do collection of this data, and it wrappers it in HTTPS for secure transfer to our backend. We actually have some folks who already have a presence in Equinix, which is where we host our backend, and will do PNI to us, a cross connect right in Equinix. and that keeps that traffic off the public internet. So lots of different ways you can get the data in.
Okay, great. Another question is, my organization would have a hard time considering sending our network data to a SaaS. What answer do you have for that?
Well, there's a couple of different ways we've been dealing with that. We've talked to a lot of people who have similar concerns. And a lot of them are, once we walk through the process of how we handle the data, are okay with trying this out. We're also working on a private SaaS model, where as opposed to keeping your data in the same system that we are with others. By the way, one of the reasons we had to go to our own implementation of a backend was so that we could implement and enforce true separation of data and multi-tenancy, which we do in our backend platform. But if that's still not secure enough for you, we can set up and operate a dedicated backend stack for you. In exceptional situations, we have had conversations about putting a stack on site locally. But we find that actually, as we go through a conversation, most people end up going ahead with the regular SaaS options. So it's a conversation we would welcome and look forward to having with you about how this works and what the real process and real concerns will be.
Okay, great. One more is, does the platform require BGP, or does this work on just NetFlow data?
Good question. Given our topic today was BGP plus NetFlow, you might get that interpretation. You might jump to that conclusion, but no, you actually don't have to send BGP into our system. Most of our existing customers are bringing BGP data in, but not everybody. There's plenty of value to be seen by just bringing in and analyzing the NetFlow at scale. Some of the other common use cases for this platform include regular sustained monitoring. A lot of people are using it to catch things like DDoS, so to detect it so they can characterize it and then understand what sort of mitigation options they would like to take. There's the alerting features really are very valuable for that, but also just for recognizing a variety of potential service impacting issues and situations. So there's a lot of value that can be gathered from this platform without BGP. It just gets really interesting when you do add it for the reasons we talked about today.
Okay, and one last one I have is, and I think you mentioned this very briefly as you were introducing the whole peering analytics, but there was a question just kind of clarifying availability of peering analytics.
Right, so the peering analytics and those diagrams that I showed you, which are called sand key diagrams, by the way, the sand key diagram functionality and the BGP peering analytics have been in beta now for a couple months. We are going to be releasing them probably right around the first of the year or shortly after. So quite soon they will go out as GA. They are active today for any existing customer who's on the platform. And people who want to come and do a trial, you can, as long as you want to configure your BGP, you can take a look at them live now too. They're just beta mode right now.
Okay, great. Well, I think that's it, and we are also at our time limit. We're going to post the slides to our website as well as the slide share, and we'll send out an email to folks who have agreed to get emails with a link to the slides so you can download those. All right, I just want to thank everyone again for attending. Really appreciate your time, and we'll be continuing our webinar series in the new year, so look out for new invites and to more interesting content. Thanks again.